Hi guys, this is AP problem number 3 here, and we start out with number 1, which is methane gas reacts with chlorine gas to form dichloromethane and hydrogen chloride, which in the equation up here is CH4, which is gaseous, plus 2Cl2, which is also gaseous, form H2Cl2 gaseous, and HCl gaseous. So we go to letter A, which is a 25-gram sample of methane gas is placed in a reaction vessel of 2.51 mole, or 2.58, I'm sorry, the camera's not focusing, 2.58 moles of chlorine, which is gaseous. And we go to section I, which is find the limiting reactant. So to do this, you start out with the givens, which is 25 grams of CH4. So you multiply that by its molar mass, which is 1 mole of CH4 over 16.04 grams, times the molar ratio, which is 1 to 1, times the molar mass of HCl, which was what I used just to find the reaction there. And you get 56.8 grams of HCl. Then you start out with Cl, and you start with the given, which is 2.58 moles, times the molar ratio, which is 1 to 2, times the molar mass of HCl again. And you get 47.0 grams of HCl, which therefore means Cl2 is the limiting reactant. Next we move on to II, which is find the number of moles of CH2Cl2 after the limiting reactant is used up. So, as we learned from up here, the limiting reactant is chlorine, which was given at 2.58 moles. So, we start out with 2.58 moles times the molar ratio of CHCl2 and Cl2, which is 1 to 2, which then gets us 1.29 moles of CHCl2. And it's pretty much the same as just doing the moles divided by 2 there. So, that's it for question 1. Now to move on to question 2. Which is iron reacts with oxygen to produce iron 3 oxide as represented in the equation above. Which is up here. It wasn't balanced, so I balanced it, which is 6FeS plus O3O2 gaseous plus 2Fe2O3, which is a solid. And we go to the question, which is a 75-gram sample of FeS is mixed with 11.5 liters of O2 gaseous at 2.66 atms and 298 Kelvin, which is 25 degrees Celsius. As we start out with A, which is calculate the number of moles. So letter I, which is Fe, is solid, and we start with the given, which is 75 grams over the molar mass, which is 55.85, and you get 1.3 moles. And then we move on to II, which is O2. And for this, I use the ideal gas law, which is PV equals nRT. As we see here, the pressure is 2.66 atms times the volume, which is 11.5, equals N, which is number of moles, times the constant, since we're using Kelvin, it's 8.31, times the amount of Kelvin, which is 2.98. So these two together equal 30.59. And then these two times together equal 2,476.38. Have not considered the significant figures yet, because don't need to, just quite yet. And then divide this side by this side to leave N alone, and you get 0.0124 moles of O2. So that means O2 is the limiting reactant. Actually, we don't know that yet, I'm sorry. Then we have to plug that in because we found the moles there. And so I plug it into the equations, which is the moles times the molar ratio equals the moles found. So we start out with Fe, which is 1.34 moles, times the molar ratio of 2 over 6 equals 0.447 moles of Fe2O3. And then we get to O2, which is the limiting reactant, as you already see, and I already said. And it's 0.0124 over 1 moles times the molar ratio of 2 to 3. This yields us with a 0.00827 moles of Fe2O3, or 8.27 times 10 to the negative third moles of Fe2O3, therefore making it the limiting reactant and ending this video. Thanks for watching.